Okay, today in IM1 we're going to cover 10.1 and 10.2. So we're going to talk about these things here. So we know that two lines that do not intersect are either parallel or skew lines. That's how they never meet. So two lines are parallel lines when they do not intersect but are coplanar. So that would be M and N. They are laying both on plane T and they are parallel. Okay, so they don't intersect and they're on the same plane. Two lines are skew lines when they do not intersect and are not coplanar. So this one's kind of hard to see because it looks like M is going to hit K, but it's N that is intersecting with K. So N and K intersect, but M is parallel to N, so it's going to just go right by it. Okay? So so M and N are the parallel lines. M and K are the skew lines. T and U are parallel planes, and they don't put symbols on those, but that's how you would write it. And these lines here tell you that they're parallel, okay? And then lines K and N are intersecting lines, and there is a plane containing them. In other words, if there's a line, so you would have K and N, then there would be a plane containing them, but they didn't show that, okay? So anytime two lines intersect, there's a plane that contains them. So there's an infinite number of planes. Okay, so we already talked about the arrows that show you it's parallel. And then segment and rays are parallel when they lie in parallel lines. Okay, so if I had, a segment in my parallel lines, then those are also parallel. And the rays are parallel, etc. A line is parallel to a plane when the line is in a plane parallel to the given line. So M and N are both parallel to this plane. Okay? So that's just trying to get you if you understand all these things. Okay, so you don't get to work with a partner, sadly. So we're just going to look at this and figure out what each thing is in the box. So I wrote the first one down. So make sure you're looking at these. These are lines. So they're saying line A, B, and BC. Oh, we can see that they are intersecting and that they intersect at point B. Okay, so now we're going to look, I'm going to try to use different colors for each one. So AD, okay, AD and BC, okay, those are parallel lines. And they're coplanar because they're on the same plane. They're on this plane here, ADC, but they are never going to intersect. Okay? All right, we're going to do EI. That's this line here. And IH, well, what do you think those are? Those are called coincident lines, meaning they are collinear. All of those points are collinear, meaning same line. And I won't be testing you about that. That's a term that we used a lot in algebra, but they don't really use it much in big ideas. Okay? Then we're going to talk about BF. So BF and EH. BF is here. And EH is that one we just left behind, the green one. And we can see that those are skew lines. They're never going to intersect. Okay? And they're not on the same plane. All right, then we have EF. EF is right here. And CG. CG, oh, those are also skew and never going to intersect. Okay, and then the last one, I'm going to go ahead and use the highlighter so we can see it over all this mess. And we have AB, which is this one here, and GH, which is this one here. Oh, that's a good one. So those are parallel, and they are in the same plane. But that plane's not drawn because that plane looks like this. Okay, so that would be the plane that contains them both. So there you go. And they will never intersect either. All right, so now we have the parallel postulate. So read through that carefully. It says, if there is a line and a point not on the line, then there's exactly one line through that point that is parallel. So in other words, I could draw a bunch of, lines through this point, but there's only one that is parallel. Same kind of thing here with the perpendicular postulate. Through any point, if there's a line and a point not on the line, there is only one line through that point that will be perpendicular. I could draw this line, but that's not perpendicular. I could draw one that's really close, but it's still not perpendicular. There's only one line that would be perpendicular. Okay? Alrighty. So we're going to identify parallel and perpendicular lines. So first thing we're going to do is I'm going to put up the answers because they have really good explanations. Okay? And mainly I want you to stop, pause, and read this because this explains why FE is not parallel to AC in a different kind of way using the postulates. Okay? So you could also just say it doesn't look like it, but in a proof, you have to prove it. So that's what they're doing here. Okay, so pause if you want to read that through, and then we're going to go to this one. So this is showing another town. We want to name a pair of parallel lines. So that would be GH is parallel, and we can see that because we have these symbols here. Okay, then name a pair of perpendicular lines. So we have a 90-degree sign there. So that gives us our perpendicular lines. And then it asks, is GN perpendicular to JL? So it's asking this, and you're going to say the same thing. It's not perpendicular because these two, and by the perpendicular postulate, there's exactly one line through G that is perpendicular to JL. So again, they're giving a proof using a postulate, and that's how you set up proofs. We're not going to be doing a lot of that, but make sure you're paying attention to these explanations because you need to understand them, not necessarily have to use them. Okay? Alrighty, so now we're going to tell you about some special angles. So a transversal is a line that intersects two or more coplanar lines at different points. So I have two lines. They can go anywhere. I cut them. That is the transversal. Okay, so this is the transversal. And when it cuts them, it gives some relationships that you need to understand and remember between the lines that are existing. So if you look at this up here, you've got corresponding angles. Corresponding angles are in the same position on the angle. So 2 and 6 are both sitting on a line, and they're on the same side as of the transversal. Okay, so these would also be corresponding sides. Okay, and this one would be a corresponding side to this one because they're on the same side but under my line. Okay, so you can see what corresponding lines are. Two angles are alternate interior angles when they lie between the two lines, so they're interior, between, and alternate means they're on opposite sides. Okay, so we have one other set, and that would be this one and this one. Okay? Two angles are alternate exterior. They're on opposite sides. That's the alternate part. And then they're on the outside of our two lines. So that's what the alternate exterior lines. And then we have, angles. Two angles are consecutive interior angles when they're next to each other on the same side on the inside. Okay? Consecutive interior. Same side next to each other. Okay? Alrighty. So this is a review. Some of this is in your journal. I kind of cheated. I didn't like one of their diagrams, so I didn't use it. So if you want to pause and do this, the answers are going to pop up in a minute. But go ahead and give yourself a try. It's in your journal, and you can push pause here and figure these out. Okay, so I'm just going to put the answers up, compare to what you got, and hopefully you got them correct. If not, go back and look at each one of these to make sure you understand what you're looking at. Okay? Alrighty. So now we're going to look at, these are also on your journal, and they want you to name a couple of parallel lines. So the first thing I notice is these are parallel and these are parallel. Okay, because they both have the symbols. When you put them, they are not parallel to each other, so make sure you put this and this and this and this. Okay, name a pair of perpendicular lines. There is my 90-degree angle. Okay, and notice that they gave more than one set. So look at what they did there. Okay, and then these are going to have those explanations. Is WX parallel to KR? So look for those lines, and let's highlight them. So WX is right there, and QR is right there. So they definitely aren't parallel because they intersect, right? Okay, so that's what you want to look for. And then ST is this line, and NV is this line. And are they perpendicular? And the answer is yes. There's exactly one line through V perpendicular to ST, and it has the symbol. Okay, so that tells you that they are perpendicular. Now on this next one, I did not like the diagram that's in your journal. It was very confusing, and because you could look at it from 3 different angles, so I just decided to make life easy on you. So we're going to look for corresponding parts. So I would like you to push pause and use this diagram and fill this out, and then come back and we'll go through it together. Okay, so the corresponding angles in this diagram are angle 1 and angle 7, angle 2 and angle 4, angle 8 and angle 6, angle 3 and angle 5. And I think that's all. Okay? Now we're going to look for alternate interior angles. So we're going to go to the inside of our lines, between our 2 lines, and we're going to go on opposite sides. So angle 8 and angle 4 are alternate interior angles, and angle 7 and angle 3 are alternate interior angles. Now we're going to go to the alternate exterior, so it's the ones on the outside of our lines on opposite sides. Okay, so it's going to be angle 1 and angle 5, and angle 2 and angle 6. Okay, the consecutive interior means next to each other inside, so that would be angle 8 and angle 7, and angle 3 and angle 4. Now these names are really important, but they have much more significance in the next unit, so we're going to use them again. So make sure you understand what each of these is. So now we are on 10.2, parallel lines and transversals. So this changes everything and gives us, okay, so it says angle 1 and angle 5 are corresponding angles. How are 3 and 6 related? They are alternate interior angles. Okay, how are 2 and 7 related? They are alternate exterior angles. How are 4 and 6 related? They are consecutive interior angles. Yeah. And then how are line P and Q related? Right here. They are parallel. Okay, so there you go. So now we're going to learn about these theorems. Okay, so I got to erase all this stuff so you can see it. So notice that these are all the shapes that they gave us and the things, but there's a theorem attached. The theorem only applies if they are parallel. So you have to have these parallel lines in order for these theorems to apply. So what the corresponding angle theorem is that if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Whoa, that means that angle 2 and angle 6 are congruent because they are corresponding angles. The alternate interior angle states if two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So that would be angle 3 and angle 6 are congruent, as well as 5 and 4. Okay? Then we have the alternate exterior angles. Those are the ones that are way on the outside, but on opposite sides. And they are also congruent if two parallel lines are cut by a transversal. So angle 1 and angle 8 and angle 2 and angle 7. Okay, we're getting really nicely decorated. Now, what is so special about these interior ones? Because they don't look like they're the same. One looks acute and one looks obtuse. That's what's special. These two are supplementary. Okay, so the consecutive interior angles, if two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So angle 4 and angle 6 are supplementary, and angle 3 and angle 5 are supplementary. So these are things that you want to remember. So the measure of 3 of the number angles are 120. Identify the angles. So you have to think about what you're doing here, okay? So you want to verify the relationship first. There you go. These are parallel lines. So now we know that there are significant relationships that relate. So we can calculate the rest of the angles, okay? So that would be the next step. And it doesn't matter which theorem that you use, okay? The only thing that matters is that the theorem applies. For example, you could use corresponding angles theorem to show angle 5 also equals 120. And you could use the vertical angle theorem to show that angle 4 is, so this is the corresponding angle, right? And this is the vertical angle, so this is also 120. You could also use the alternate exterior angles to prove that angle 8 is 120. So wow, we found all of them using that one alternate exterior, alternate and vertical, and corresponding. Okay? So can you use the same theorem every time in every problem? And this is the answer. Again, the only thing that matters is that the theorem applies. For example, if I wanted to find the rest of my angles, I could use, this is a linear pair, or they're supplementary, so that would give me 60. Okay, which means this is 60, which shows that everything's supplementary there. This is an alternate interior angle to this, so this is 60, and this is a vertical angle to this one, so this is 60. So read the answers again if you want more explanation, but I just want you to be able to do this, okay? Alrighty. Okay, so I set this up kind of different. What I want you to do is, these are from your journal, page 284, and I want you to solve each one, both angle 1 and 2, but then I want you to solve angle 1 first. So here's an example. So I know that angle 1 is an alternate interior angle to this, so I can tell that it's 110. Then I would say angle 2 is also 110 by the vertical angle theorem. Okay? All right, so you guys can go ahead and push pause and do 2, 3, and 4, and then we'll come back and do them together. Okay, for number 3, angle 1 is 95, and we know that because it's a vertical angle to 95. Then I can find angle 2 equals 95 as well, but by two different methods. I could say it's the corresponding angle to this one, so I could use corresponding angle theorem, or I could use alternate exterior angle theorem to compare it to angle 1. So make sure you're looking what is available, okay? What is there for you? Okay, now look at number 2. We have angle 1 is a corresponding angle to 63, and now we have to figure out angle 2. So we could find out angle 2 is a consecutive interior angle, to angle to 63 degrees. So we could say 180 minus 63 equals 117. We could also say angle 2 and angle 1 are a linear pair. And so that would be another way to find out that it's 117 degrees. Okay, so look at all your options. Okay, over here we find angle 1 because it's a vertical angle. And then we could also find angle 2 because it's a corresponding angle to 101. So it equals 101. And it's also an alternate interior angle to angle 1. So it equals 101. So there's lots of ways to do this, okay? All right. For these kind of problems, you have to solve them a little bit. So, and I want you to justify them and use the theorem. So the first thing I'm going to do is, I know that this is an alternate exterior angle to this, so I'm going to go x plus 12 equals 110. So we're solving for x. Subtract 12, and x equals 98. Okay? Now, what theorem did I use? And I set this up and I forgot. So there's all the work. The alternate exterior angle theorem. So now what you're going to do is push pause and solve the next 3 in your journal and see how you do. Okay? And then we'll put the answers up and you can check. Okay, so here's your answers for all of them. Check to make sure that you're using things the way you should. This one's giving you options down here, so make sure you understand that. And with that, we are done, and you have an exit ticket. So here is your exit ticket. You are going to be using this diagram for these 3, and for 1 and 2, you're going to be using this one. Notice that you're going to be giving me the theorem that you used because I want to make sure that you understand it. Also, before I go, I'll just let you know, point out that these 2 lines are parallel, and these 2 lines are parallel. So use that when you're thinking about it. So think of them as going on forever. It does sometimes helps to do that, and that might be a way to help. So take care.